Hello everyone, I'm out again today. I'm going to be at the regionals for today. So anyways, I just want to go over some quick stuff. I know we know Pythagorean theorem, but I'm going to go over it again here. So what is Pythagorean theorem? Pythagorean theorem is a squared plus b squared equals c squared. Okay. Now the converse of the Pythagorean theorem is just taking that Pythagorean theorem and writing it backwards. So instead of writing it a squared plus b squared equals c squared, we're going to write it c squared equals a squared plus b squared. And you're going to see why I'm doing this here in a sec. But it's going to help us determine what kind of triangle we're looking at. So anyways, next slide. All right, so here's a type of question you might see now. Using that converse of Pythagorean theorem, it says, what kind of triangle has side lengths of 5, 12, and 13? Okay, and it says, how do you know what kind of triangle this is? So if we were to write out c squared equals a squared plus b squared, okay, and then we were to plug in those numbers, we can see that maybe it's a right triangle, maybe it's not. So in order to tell that it's a right triangle, though, we have to plug in these numbers in the correct spot. And remember, the longest side is side C. Now, if this was a picture, the longest side would be across from the right angle on a right triangle. So obviously 5 is A, 12 is B, 13 is C. So if I were to write this out now, it would be 13 squared is equal to, okay, 5 squared plus 12 squared. And we want to see if this comes out equally, okay? Well, 13 squared is 169. 5 squared is 25. And 12 squared is 144. Okay? So if you add 25 plus 144, you do get 169. So you get 169 equals 169. Now, if both sides of this are equal, we can now say that this is a right triangle. So that checks out. We have a right triangle. Okay? All right. Erase that. Okay. So that's how you would get a right triangle. All right. All right, so let's look at this one. We want to see if this is a right triangle. And if it's a right triangle, both sides of the equation should equal each other. So here we go. So we're going to go c squared equals a squared plus b squared. Okay, and so when I do it, I get 12 squared is equal to 6 squared plus 8 squared. Okay, and so when this comes out, I get 144 is equal to 36 plus 64. When I put it all together, we get 144 equals 100. Well, okay, so before they had to equal each other to be a right triangle. So now we have a situation here where the c squared side is greater than the a squared plus b squared side. All right? And so right now we got 144 is greater than 100. All right? So now we have to think about, well, what kind of triangle is this? So with this in mind, okay, a triangle that has c squared greater than a squared plus b squared is an obtuse triangle. Okay, so now we have an obtuse triangle. All right. Okay, so now I'm going to write out c squared greater than a squared plus b squared, and so that's obtuse. So that's now another way we can identify a triangle instead of it just being a right triangle, now we have an obtuse triangle. Okay. All right, so here we go with another one. We're going to go c squared, okay, is equal to a squared plus b squared. Okay, so then now we're going to plug in, well, obviously c is 16, so we go 16 squared equals 8 squared plus 15 squared. Okay, so now I multiply those out. I get 256 equals 64 plus 225. Okay, and then when I write that out, so you get 256, okay, and on the right side you get 289. Okay, well obviously the left side is smaller than the right side. So when c squared is less than a squared plus b squared, we get a triangle now that is an acute triangle. Okay, so c squared less than a squared plus b squared. It's an acute triangle. Okay, so now you have three types of triangles. Okay, so we're going to kind of conclude the last two sheets here. Okay, so all right, so here's a little bit of practice to do. This one, it says, given the measurements 8, 5, and 4, is it a triangle? So first thing, how do I know if something's a triangle? Well, obviously you got to add up the two smallest sides. Okay, 4 plus 5. Is that greater than 8? Okay, well, obviously 9 is greater than 8. And we can do this for all the sides, but obviously they're all going to be bigger than the smallest side if we keep going through. So mainly, you really need to know that the two smallest sides are greater than the biggest side, okay, when you add them together. So, okay, so is this a triangle? We're going to say yes, okay. And so now, if it is, what kind? Okay, so now we got to go through our converse to the Pythagorean theorem. So we go c squared. Okay, I'm going to put a question mark instead of an equal sign. A squared plus b squared. Okay, so we're going to go kind of backwards here with it again, like I was showing earlier. And so we got 8 squared, question mark, 4 squared plus 5 squared. Okay, so 8 squared, obviously 64, question mark. And then we go 4 squared is 16. 5 squared is 25. Okay, so if I go 16 plus 25, I get 64, and then 16 plus 25 gives me 41. So obviously the left side is greater than the right, so we say 64 is greater than 41. And so if the left side is greater than the right, we say it's an obtuse triangle. Okay. So what kind? We say obtuse is our answer. Okay. All right, let's go on to the next one, and we want to see what kind of triangle this is. So we're going to do the same thing. Okay. So over here, I'm going to do. Okay. Obviously, now if you're wondering what square root of 33 is, it's about 5.7 when you plug it in your calculator. Okay. So obviously 7 is the biggest side. So we got to go. Okay. C squared equals. Oh, sorry, I meant to say question mark. Okay, question mark a squared plus b squared. Okay, so c squared is 7 squared. Question mark a squared, so it's 4 squared plus square root of 33 squared. Okay, so if you remember in the past, when you square a square root, okay, it becomes itself. So square root of 33 squared is just 33. So when I do this out, I get 49 question mark 16 plus 33. Okay, so don't panic when you see a square root and you square it. It's not a hard answer. Square root of 33 squared is just 33. Okay, so 16 plus 33, I get 49. So both of them are equal. So I'm going to put an equal sign in between. 49 equals 49. Obviously, this is a right triangle since they're both equal. Okay. So let's see if we can answer these questions. Is this a triangle? Well, is 4 plus 5.7 4 plus 5.7 greater than 7? Well, yes. Okay, so yes, it's a triangle. What kind of triangle? It's a right triangle. And we did that over there to the left to tell if it was a right triangle, obtuse, or an acute triangle. All right. All right, so we're going to conclude everything together, okay? So if the triangle is acute, then c squared is less than a squared plus b squared. Okay? If the triangle is right triangle, it's c squared is equal to a squared plus b squared. And if it's an obtuse triangle, c squared is greater than a squared plus b squared. Okay? So now, hopefully these notes help you with that worksheet that you're about to get. So here we are in the worksheet. Just want to get you a little started and see, so you can see what's going on. So I'm going to do one of them for you. Let's look at, obviously, number 4. Looks like a good choice, okay? So if they want you to classify the triangle as acute, right, or obtuse, okay? Obviously, we're going to use c squared question mark a squared plus b squared, okay? And that didn't write out so well, did it? Over there. Okay, so we're going to use c squared question mark a squared plus b squared, okay? And so I'm going to use the numbers and plug them in. Okay, our c is 3, okay? A would be square root of 3 and b would be 2, okay? And so we're going to go 3 squared, okay, is question mark 2 squared plus the square root of 3 squared. Okay, so 3 squared is 9, 2 squared is 4, and square root of 3 squared is just 3. So let's see, 4 plus 3 gives me 7. And then we got 9 on the left side. Obviously 9 is greater than 7. So if 9 is greater than 7, we say it's obtuse. Okay, it's an obtuse triangle. All right, so that's how you would do number 4. And if you were to now do the rest, you should have an idea now. Okay? All right, that's it. Thank you.